Hello everyone. Well, we've got 6 o'clock, so we're meant to start. I'll give maybe 1 or 2 minutes, for more people to join, but I can see we've got quite a few of you already watching. So, at very first, we're usually running those meetups in our London office. I'm Patryk from the ECS. I'll put a little something so you can see me now. Hello, hello. So there's a face to what I'm saying, hopefully. Like I said, we're usually running those meetups in the ECS office. As an ECS, we are a digital consultancy. And as our give back to the community, we're running those monthly workshops when usually some of our consultants are trying to share something new, something interesting. Same goes with today. I'll ask for patience and understanding as we're doing it for the first time. I'm just a humble DevOps engineer, not a fancy YouTube streamer, so just please be merciful on me. I'll try to do not waffle too much and make it fairly quick. There will be a few, let's say, organizing things I will go through in the following minutes. So the first thing first, we are believing in a hands-on approach, so or our labs are hands-on. You are getting your instance. Well, two instances in this case, as we'll be working on two servers. So to do so, there is a link below. It's just an S3 bucket. I didn't assign the DNS for it. We'll be there next time. So if you get on this link and you put your meetup username, so the one you registered with on the meetup, I'll just use the test user for that sake, and you submit it. You should see your instances in the following format. It should be master animal, worker animal, and it will be a username and a password as well. As it's written here, to actually get on the instance through your web browser, just add /wetty to the instance. You should see something alike here. I'll just keep my session alive, so once we get on the hands-on session, I've got something to go for. There's also all the instructions, so all the steps I will be going through today are included in the README of the repo. So there will be like a step-by-step instruction. Most of the commands you can just copy paste. So if there is any point when you're getting lost, please just refer to the README. The comments section is active, so drop any question on the comments. If you want a bit more, let's say, direct support, we set up the Slack workspace, so please feel free to join. It's just a free community workspace. But we've got a few guys from the ECS looking at the space, so if you've got any questions, just feel free to go there. There are also some Slackbot responses, so like a basics like a README or something like that. You should be able to just message yourself and get some reasonable response. Right, I will repeat it again after the presentation. I've got a few slides first on what the Docker is actually, why we would use it, what's the advantage of using Docker, and then why would we use an orchestrator, but what are the differences in a very short version between the Swarm and the Kubernetes. So we'll go through that shortly. I believe in doing rather than saying, so I'll try to be brief and just focus on the main points over there. I will advise you to follow the structure of the tabs like the one I have. So I have my README here in the first tab. Well, I've got my credentials in the first tab, my README in the second one, then my first server, my master node in another tab, then my worker node, then I have another two tabs. Those will be our testing tabs. We'll actually deploy some applications here, so we'll be able to hit our instances. So good to have those another two. So that will just, I'm not saying you have to do it, but it will just make your life easier and your experience smoother, I suppose. So moving on, a few words on the containers. I will get to the slides. So yeah, our topic today is hands-on container orchestration using Docker Swarm and Docker Kubernetes, but obviously we can't do it with just a good old Docker and with containers in the first place. So as I said, the agenda looks more or less like that. A quick presentation, hands-on session, and at the end, the Q&A section. So please pop your question in the comments, or feel free to use also a Slack support channel. I will try to gather them and with the help of our support team and answer them at the end. One more thing, as we, and I think it's one of the most important ones, as we usually hosting those meetups in the office, we provide some drinks and a pizza. Well, we didn't manage to get a pizza for every single user who's joining us today, but we've got a little treat at some point behind me, where my girlfriend in the panda t-shirt will appear. So normally we've got Ellie from ECS wearing an amazing panda costume and blending in on our workshops. We can't do it today, but we'll have a glimpse of it. So if you will spot a panda, please drop a comment. The first person to spot it will get a little treat from us. So again, our team will contact you to iron out the details. But tomorrow pizzas will be on us then. Right. So containers. Let's start about those. What are actually the containers? And in a very short version of the, because we could go on and on for an hour what the containers actually are, but I think the simplest way to explain how the containers work is to compare them to the virtual machines. So the good old virtual machine, we've got some physical server, and we're dividing that server to the chunks as we please, assigning some memory, some CPU, but we are assigning those resources as we see here. Permanently, we need an operating system running there. We need every single, let's say, virtual machine needs its own kernel, and just by the hypervisor, it actually communicates with underlying infrastructure. That's completely different in terms of Docker. We don't assign, let's say, 2 gigs of RAM and 1 virtual CPU per our container. Yes, we can limit our resources or set the resources to this certain value if needed, but generally speaking, the resources, physical resources on our host are assigned dynamically to our container. Hence, we can squeeze more instances of the application and distribute the load a bit more efficiently rather than have some idle virtual machines just running and doing nothing. So yeah, that's the main difference. And what's actually interesting about the containers and why would we run them in the first place? So the first point I noted here is isolation of the process. So I like to joke that what happens in the containers stays in the containers, a bit like in Vegas. It's not always the case. There are some exceptions, of course, but generally speaking, the processes which take place inside the container are isolated. The containers don't know about each other, don't know about what happens in other containers unless we specifically tell them to. We are exposing the services or the channels of the communication with our container as we please as well. We've got a lot of flexibility thanks to using the containers, and we, again, using the resources of our host, of our physical or cloud infrastructure for that sake, pretty effectively thanks to the nature of the containers. They also fit one of the modern, let's see, architecture design principles, where we treat our infrastructure rather like a cattle than like a pets. We don't, if our server feels bad, we don't take him to the vet. We don't spend huge amount of money on bringing him back to life. Now we just remove it, bring one up, and that leads me to the short lifespan. We can spin up the containers usually in seconds. Of course, with the more complex configuration, it will take a bit longer, but still comparing to spinning up the new VM, that time is miles different. Another thing, I think if anyone works in developer environment, had at some point of his career Yeah, it works on my machine. Well, with the Docker, ideally we won't hear it at any point, because once we design our applications and containerize them straight away, if our developers, let's say, have MacBooks, can run Linux containers on them, those containers will be working the same way on our Linux servers. There will be some different, some caveats, let's say, across Windows and Linux. But let's say, generally speaking, we've got way more consistency with our developments, and I'll show a bit more about that once we get to the hands-on session. And obviously, last point, they are really lightweight. So the full Linux distribution, obviously with the bare minimum, can take even 5 megs, taking Alpine Linux as an example. Okay, so we got those awesome containers, but let's see if it's one, if it's two, it's pretty easy to get a hold of it. It's pretty easy to manage. But if we're thinking of, let's say, the enterprise scale application, when we've got hundreds or thousands or even more of the containers, we need some handy way of managing them as a whole group. We won't be looking at each container. Let's say personally, we need a tool to actually take that from us. So here the container orchestration is coming in. What are the main, let's see, areas when the container orchestration can help us? First thing first, well, it provisions, deploys the containers as we please. So take care of the deployments, and then we can automate them, we can version them, as we're going to see later on in our hands-on class. Scaling up or down the infrastructure, as well as load balancing, is also handled by most of the container orchestration tools. It helps with general, let's say, managing of our services. We can create nice workspaces, define the services, and let's say refer to our application as a services rather than the servers, containers, or the units of that sort. It also handles a basic health monitoring. We can expand on that. We can also, like, say, have additional monitoring tools on our cluster. What's important, it monitors our containers as well as monitors the host. Well, with the containers, I think Swarm is losing the momentum right now. I was writing those workshops a year ago where it was still a bit more applicable, but it is still a nice example of how the things are working. But generally speaking, if you will see the discussion, there will be probably more vigorous supporters of the Kubernetes, which makes perfect sense, but also leads me to the next slide, which I found on our company Slack at some point, which illustrates the learning curve of a different container orchestrations, as well as the possibilities which they give. And we can see that the curve for Kubernetes is, let's say, complex. It would be an understatement. It is a bit of a hell sometimes, especially without any previous experience, and when we want to have a very complex bespoke configuration. Like I said, with the great power again comes great responsibility. So yes, Kubernetes is powerful. We can configure a lot, but it will require some a bit more management and a bit better skill set to actually keep alive, which might not be the case for the small teams. And then we can, let's say, lean to a different solutions like Swarm, or maybe on one of your cloud provider managed service like ECS, for instance, on Amazon Web Services, for instance. Right, so shortly, I hope I introduced everyone to what we will be doing. I will move slowly to the hands-on session, just sense checking the communication and see if well, nothing exploded yet, and hopefully everyone can following. Just 1 second, I can see that some users are experiencing the issues with getting the instance details. So I'll try to just quickly address that. Again, it should be your Meetup username. I'll try to share, well, let's say the list of users with the support team if we just pulled it from the Meetup. So I didn't have anything really to do with the list itself. But like I said, I'll try to sort it out before we head to the hands-on session. Right. I'll please, like, if everyone can just give a shout if we can proceed, if we can get let's say on the hands-on session. I will already move to my, let's say, hands-on tabs. Hopefully, I didn't get kicked off of my instances. Well, not yet. That's a progress. Just on our instances, just so you all know, if someone joined the meetup like really last minute, it might be the case that your username is not there. For the guys from the Edinburgh, I was updating the list midday for the folks from London from London meetup. I did it maybe half an hour ago. So yep. I can't see any screens that we can't proceed, so I'll move on to the first exercise. So the first exercise you'll find in the README on under the section Deploy Web Application as a standalone container. So what we're going to do here, well, it's pretty self-explanatory. We're going to build a container and we're going to deploy it. What else we can do with it? Right, so I'll ask you to move to the master instance, so the one which DNS address starts with the master. If you type ls, you can see that you should have the repo with everything you need for today's workshop. So let's just get into that directory. You can do that just by typing cd capital H and tab, and there you go in our main directory. So if you have a look, we have app, we have docs, which is basically the README. We have HAProxy, Kubernetes, and scripts, which basically includes how to set up the instance you're working on, but for CentOS, as far as I remember. I'll add the Ubuntu script as well as we're working on the Ubuntu instances. So if you would like to, at some point, repeat this experience for some reason, I'm not judging. You can just grab the script, pass it as a user data to your EC2 instance, and you're good to go. Yeah. Cool. I'm sorry. Believe me or not, I did the DND, so you shouldn't get notifications about getting them out. Anyway, cool. Right, so the first things first, let's move to the app directory. This is where our application will actually be. So as you can see here, we've got Docker file, which will be the file for our image. We've got application file and requirements file. I'm usually picky, so just to have a quick look, the application itself is very simple. It's just a Flask service saying hello, taking an environment variable name, and displaying that as you will see shortly. And in the requirements, as you can guess, we just got Flask because that's all we will need to build our image. So what is actually interesting us, and as you can see in the next step, will be the Docker file. We'll edit our Docker file using my favorite text editor, Vim. And I'll stop here for literally 1 second. With using Vim, not everyone is familiar. That's quite a specific text editor. If you want to, let's say, navigate, you can use your arrows. If you want to edit something, you need to press I to get into the insert mode. So you should see in the bottom left of your screen, you will have insert. In the place when I have Patryk, you should your environment variable name should say your name. So please put your name there. Could be name of your card. Again, I'm not here to judge. This is just a nice exercise. So once you edited the environment variable, if you want to exit the insert mode, you need to press escape. And to save the changes, we need to press colon and X. And if we follow that by enter, the changes will be saved. I'll stop for 1 second on the Docker file just to say a few words of what's actually happening here. So the first line, which is saying from, tells us that we're going to use some base image to build our image. That's going to be Python 3.7 running on the Alpine distribution. In our image, we're going to create the work directory, and we're going to copy the contents of the current directory to the app directory. Once we did that, we're going to run pip install, and we're going to grab our requirements. So we're going to install all the requirements, which is just Flask in this case, but just to show that we can source the requirement from the external file. Obviously, with the more complex projects, you'll have a million of dependencies, but it's just an example. Then the next line, expose will expose port 80 on the container. So this container will allow traffic on the port 80. If you'll try 81 or 79, no way. Port 80 nevertheless will be exposed, so the communication there will be allowed. Environment name will set a system environment OS environment variable, which will be available to our application, as you will see later on. And when I was having a pick on our application, I think it's a bit of a statement there, but if there will be an application there, once we will spin up the application, that environment variable will be there for us. And the last thing, we've got entry point. Entry point is the command which will get executed once your container is getting spun up. There is also a command as an option. The main difference will be that the command could be overwritten by you when you add an argument, a command after the name of your image, while the entry point will be executed. If you will add something to the entry point, it will be passed as an argument to, but the command itself won't be overwritten. So let's build that image. To do so, we need to grab this command. What happens here? Well, let's paste it and see. So we're basically saying, hey, Mr. Docker, build the image for us. We've got a tag attached to the image. Well, we've got a tag flag we're using to give the name to the image. I called it DevOps PG, like DevOps Playground /web app. And after colon, I specified the version of this image. That's basically the convention that after the colon, you have to give you should provide the tag. And at the very end, we've got a little dot which says, hey, Docker, look for Docker file in the current directory. We could use the flag -- file, specify the path to the Docker file. It doesn't have to be named Docker file if you specify the name. But once you call it Docker file, Docker would just find it in a nice manner. What happens once we executed the command? So you can see that it all happens in the steps, and all step got a digest. So basically the way the Docker builds our images, it builds it in layers. And first it pulled the image Python 3.7 from the Docker Hub, as I didn't have it locally on this machine, created the work directory. And as you can see, like every single bit returns us a hash. It's not a full hash of the layer, but it's just a partial hash. Nevertheless, if I would change at this point this environment variable and would like to build that image again, the Docker will find that, hey, we already got those 5 layers. There's no point to recreate them, to take the disk space again. Let's just build on the top of that. So it's a really nice way of how Docker is handling those things. Right, so we've got our image. Like, if you don't believe me, and I'll test myself every time I tell you something, we can type docker image ls, which will list our images, and you can see that DevOps PG web app with the tag 1.0 with the version tag is already there. Right, so once we got an image, I think the natural step will be to just run it. And again, I prepare in the readme the run command. I'll quickly walk you through on what's happening there as well. Let me just clear my terminal to make a bit more space there. Okay, so what I started this container, it returned me the container ID, the full ID. If I'll have a look on Docker PS, which shows me the running containers, we can see that it's already up and running. What happens in the run command? Just coming back here. So we're saying Docker run the container, give that container a name, web app, run that container in a detached mode. What does it mean? If we wouldn't specify that flag, let's say our Flask command will run in our terminal. While we're saying in the detached mode, it just happens in the background. Then that's an important flag. It's a flag publish, and with this flag, we are binding the port 80 on the container with the port 8080 on our host. And at the very end, we're using the name of the image, which is DevOps PG /web app 1.0. So if we go to our tab number 5, when we've got our master instance, and we type colon port 8080 at the end of the URL, you should see that our application is up and running. It says hello Patryk, the environment variable I provided, and it also displays the host name. And that's an interesting one. As I told you, that what happens in the container stays in the container. So our container doesn't really know what is our actual host name. So the Python as a host name displays the container ID. So you can see it here in the Docker PS. The same ID is provided as a host name. Because from the OS perspective in our container, that's how the host name is defined. So I will have a look on the comms if I have any emergencies again, if anyone have any issues, but I don't see anything flashing. So the next step will be, maybe not as exciting, but we're going to do the same stuff on our worker instance. For the sake of exercise, but as well, we will need a running image on our worker instance for the next exercise. So I'll do it quickly this time, just to do not a drill on the technicalities. We did it already on another instance. Again, up your preference, but I, for instance, added to my Docker file a different name. I set unicorn just to differentiate those two hosts. Nevertheless, the host name displayed will show us how the traffic is actually going through those instances later on. So once our Docker file is edited, once you added your name there, let's build the container. And again, I'm just stealing the commands from here. So it will do exactly the same. I'm building it on the same node. That doesn't really make any difference. So let me build it, but on the right machine, on the worker node. So yeah, as expected, it will pull the images again, because on this host there is no image of this kind. But when I executed it on my master node again, as you can see, it wasn't pulling the images anymore. It just founded them locally and basically run everything again, just quicker. Right, once we build the image on our worker node, I'll just quickly clear my terminal to just make some visibility here. Again, we've got a container. Why not run it? So let's copy paste the running command on our worker node, and that should be up and running already. Let's check it by Docker PS. Looks good. And again, let's go to our worker testing tab, and let's type port 8080 here. And you can see, hello, unicorn. We're going to the, we can see the different environment variable from the different host. And the host name will respond to the container ID here. So we've got two containers and two different servers. Sounds good, but well, if you think of it, like in the real world scenario, we wouldn't be, let's say, providing, well, worker instance to my customers starting from A to E, and let's say from E to whatever my different address. We need to find some way to actually manage the traffic, to have something in front, to direct it to our servers. So here, the traditional way of doing it will be, well, let's deploy some load balancer in front of those instances. So that's what we're going to do in the next step. So on the README, let's just move on to the lesson number 2. Or just so you know, like if you use Slack as a support channel, you can get all those READMEs as well by just typing, well, preferably to yourself, not to the channel. Let's say april.x2 or april.x1, april.x3. If you prefer to see it on Slack, it works as well. Right, so moving on, let's get out of our app directory. We're going to do all of it on the master node. So let's just keep it on the master node. So I'll just quickly clear my terminal again to have some more space. We are in the app directory. So let's move up with cd 2 dots. And once we move up, let's edit our HAProxy config file. So I'll stop for a second. Yeah. Here. Okie dokie, so I've got some swap file here. I must have started editing it at some point, so I just need to get rid of it. Apologies for the inconvenience. As I said, we're doing it for the first time, so there's always something funny coming up. I'll just get rid of this swap file. Suppose I've been playing around before. Cool. We've got our HAProxy config right here. So I'll walk you through. That's a very, very simple config of the load balancer. So basically, what happens here? It does a simple round robin across two servers, and it also performs the health check. So if one of the nodes will be down, it won't redirect the traffic to the node which is down. So as you can see, we've got just the generic host address colon port. So what we need to do now, we need to get our server addresses. So let's grab our master address with the port, edit our Vim, our CFG file. So let's get rid of those and paste the address. Well, I'm afraid if you have the same problem and your smart Chrome copied HTTP and you just need to delete it. So that will be the master node. And we're doing the same with our worker node, which I'm going to grab from here. Okay. And again, just delete the HTTP part. And that's how your configuration should look like. So let's save this, escape to get out of your insert mode, and let's save this file. So we've got our service provided. And obviously, once we got that configuration ready, well, it's time to run load balancer. Before running the command, I will stop for a second here. So we can see familiar Docker run, we can see familiar detach, and well, the name flag, which gives the container name. I think load balancer is a reasonable one here. And then we got a flag volume, which we haven't seen before. So what the volume does, the volume binds directory on our host to the directory on our container. So it is one of those cases where the container actually knows something about the host. We can specify the directory, which is actually available from the container. So the container will see our HAProxy file. Just on that note, just please make sure you're in the main directory, because here another little thing about Docker, in the Docker command, you can use a backticks to evaluate your shell commands. So we're going to use pwd, which gives you your path, your current path, and then /HAProxy. So just make sure you're in the path which has HAProxy right after, and it will bind it to the default location of HAProxy configuration for HAProxy. We're going to publish port 8081 this time because 8080 is already taken for by our web app. We're going to use HAProxy image. We don't have HAProxy image on our local machine. We didn't specify any tag. So what the Docker we're going to do for us, it will just look for the latest image of HAProxy. It will pull it for us and it will run it for us straight away. So let's do that, and let's execute it here. Just on the node, if you type pwd, you should see more or less this path. I just didn't want to include massively long path in this command, which is already fairly long. And I also I wanted to show that, well, you can actually evaluate your commands in the line of Docker. Okie dokie, so again, funny stuff. I seem to have a port already binded, so okie dokie, I just I seem to run some container which I didn't mean to run, but there's nothing we can't recover from. So I can just remove this container with flag first. I don't know why it's running here, to be honest. I must mess something up with my instance, or maybe it was one of you who's doing something on my instance. Hopefully not. Right, never mind. I'll remove this container. Interestingly, you can pass the whole ID, but if you got just a few containers, you can just pass the partial. It'll iterate through your containers and delete one with the matching record. So let me run again. Okie dokie. I need to remove the container I tried to run. So again, apologies for all the inconvenience. Well, on the other hand, if anyone fall behind, well, at least there is some time to catch up. I just need to do a little clearance here on my instance and URL krill. Well, shortly move on. Cool. So I've got one web app running, and I still got that old container which is taking my name. Removed. Well, and now finally my HAProxy command should work as HAProxy container should work as wanted. As you can see, my proxy container is up and running. So if we will have a look on our master instance, please bear in mind we binded port 8081 here. So let's just jump on this one. So, well, that's familiar. We've got hello Patryk. So not much change here. But as you can see, as we refresh that page, our load balancer actually alterates between our two hosts, choose different environment variables as well as we set it up in our images. And as I said before, if we would like, for instance, one of our containers will go down. I move to the worker node right now. I'm looking, well, there is one running. Let's stop it. So I'll just type docker stop. I'll just grab number 6 because I only have one container, so it will find it. It'll take 1 second to actually stop it. Maybe more than 1 second, maybe 2 or 5. But eventually it will stop it to verify I can have a look. No containers are running. So if we jump again on our testing tab, port 8081, we just killed the unicorn. And if we keep refreshing the page, well, now we only see the Patryk because well, our health check on the load balancer prevents it to direct the traffic to the instance which is not responding. So it all starting to getting some shape. I hope. Well, it's nice when our traffic is actually redirected by load balancer. Well, nevertheless, we need to have some script, something to add those instance addresses to load balancer, or remove as we change them if that's the case. So we still need some level of management. I think the container orchestration tools are actually taking us even further in terms of like how smoothly we can manage our applications, our scale our applications. Because, for instance, if we would like to have to add more instances, we would have to add those instances to our load balancer, for instance, so he is aware where to direct the traffic. We can do it once it's running. We can just edit the file on the host, and it will update that configuration. But still, it's something we need to do. So just a quick question to remove all the containers, running containers or stopped before we move to the next exercise, just to have a clear page to move from. So I'm going to use Docker rm-f, which is flag f, flag force, will allow me to remove running containers. Without it, Docker will just prompt me that, the container is running. Are you serious with this one? I also evaluate Docker ps/a/q. What the Docker ps/a/q actually does, just so you can see, it basically run the Docker ps in the quiet mode. So it will just return the IDs of currently of all the containers, which will get evaluated. So it will just remove all the containers. So let's just quickly execute it on both nodes. So it's all nice and clear. Here goes the master. Here goes the worker. Let's have a look. Docker PSA, nothing there. The same goes with master node. Hopefully, all good. So we can move to the exercise number 3, which will take us to the Docker Swarm. So let's move on to the next lesson. First thing, what we're going to do, we're going to create a swarm. So we're going to create a swarm cluster on our 2 nodes. It's not as hard as it sounds. To start with it, we need to grab this command, Docker Swarm init initialize, and execute it on our master node. Just please follow those master worker nodes. It will have more and more meaning as we go through the exercises. So we can see that Swarm was initialized. That's the current node. It's a manager. And we've got a joining command for worker. If we need a joining command for another manager, we need to type this one. If we lose this command because we will be reckless and clear our screen, we can type Docker Swarm join token worker instead of manager. So just quickly on worker, master, what's going on here? So the Docker Swarm, it's doing a lot for us, as we will see once we start deploying applications. So we've got a master node, which is responsible for the communication within the cluster, service discovery, load balancing, and so on and so forth. In Docker Swarm, we can normally run the containers on our manager. That's fine. In Kubernetes, for instance, by default, our manager is not even schedulable for the jobs. Again, we can change it. Same goes with, it goes both ways. We're actually going to do it later on with Swarm. We want our Docker Swarm managers to be alive. If the manager is down and we've got just one, our cluster is down. So our application is down following that. We don't want every node to be a manager because it takes certain resources to actually, fulfill that managing function. So we're usually looking for certain resilience. By the definition, more than 50% of our managers in a cluster need to be up and running for our cluster to be alive. So if we got 2, 1 goes down, cluster is down. So bit of a pointless. Nevertheless, if you got 3, 1 goes down, you got still those 2 managers to fall back. If we got like a bigger deployments, let's say we deploy 3 managers per availability zone in 3 availability zones to have a bit more resilience, let's say, in a bigger application. So we got that joining command. Let's grab it and let's join that swarm on our worker node. So we've got everything ready to deploy our applications. So quickly paste the joining command. You can see joined swarm as a worker. And again, just to test it, if you don't believe me, we can type docker node ls, which will list our nodes. We can see the one with the asterisk, the one master node, is a leader of the swarm, and it is also a manager for that sake. Right, so we've got the cluster. It's up and running. So let's deploy the service there. So I would like you to grab this command, and I'll say a few words what's actually going on here. I was saying Docker. Well, we want service created for us. Again, we're using flag name to give it a name, flag publish to bind the pod on the host to the pod on the container. The new one is the flag replicas. So in this scenario, we're going to spin up 2 replicas of this service, which will be basically 2 containers. If our service would be like a bit more complicated, and we would use, for instance, YAML file to describe it, in one service we might have, say, more containers than one. Again, it's just a simple web app, just an example to just give you a glimpse on what's going on there. So let's grab it and execute it on our master node and see what's going to happen. So as you can see, well, something is going on here. Some 2 instances are getting prepared and verified for that sake. And in those 2 seconds, we should have our service up and running. So we can have a look on Docker service PS when we need to provide the name of the service, which was web app in our case. You can see that we've got 2 instances running, one on our worker node, one on our master node. We can quickly verify that by just typing Docker PS on each of them. And we can see again that we've got 1 container here, 1 container here. So I promised you in that presentation that, well, the orchestration tools will handle load balancing. So, well, how to enable it? Well, you don't need to. Let's just go to our testing tab. We're coming back to port 8080. We don't have an additional service. Let's type it. And, well, we've got something different here at first. We've got hello playground. Where did that came from? So that's where did that came from? I actually updated the image named exactly as the image we created to the Docker Hub, just to show the behavior and the difference in the behaviors here. Docker Swarm, at the first instance, will try to source the image in your configured registry, which by default in our Swarm will be the Docker Hub. So it finded the image in the Docker Hub, pulled that image, and created the service running that image on both instances for that sake. So if we refresh this page, and remember we still hitting the only the master instance, it already redirect us between those 2 services. We can observe that behavior by seeing how host name is changing. What's going to happen if we hit the worker node? Exactly the same. It will again discover the service, and we can see that load balancing is already handled. Right, but that's not everything which the Docker Swarm does for it. I mentioned scaling, so let's scale up our application. Let's say, well, we're going to do it manually, but we can have a certain events set up. We can set certain metrics on the container. So let's say if the CPU usage is over 80%, spin up a new container, or just another 2 containers. Well, the possibilities are basically endless. Whatever you need to configure, you probably can find a way of doing it. So let's scale this service. Pretty straightforward. Docker service scale, name of the service, which is web app, and here we're putting desired number of instances. So we already have 2, so 1 more should be created. Let's have a look if that's actually the case. Most likely pasted some wrong command. Never mind, nothing exploded, so that's fine. Cool. So we're scaling the service. That was fairly quick. Verify. Looks like it's running. And again, just quick look on the Docker node ls. Docker service PS, I'm sorry. Web app, just to have a look. We've got another instance of our application. It's running on the master node. Let's have a look. Indeed, we've got 2 containers now. And if we're going to hit our, let's say, worker node again, we should see that now we've got 3 different hosts, which our traffic is altering. It's a simple round robin in terms of how it's load balancing the traffic. Again, something if you want to configure it a different way, you most likely can do it. Right, so we deployed our application, it's up and running, it's scaling. Of course, if we want to scale it down, same principle, web app, just, well, number 2, number 1, whatever it's your desired capability. I mentioned that master nodes are usually not schedulable. So what we're going to do now, let's assume that we want to do the things right way, and we want to have certain resilience in our cluster. We don't want any works to run on our master node. We've got 10 workers. Why so? So let's just quickly come back to Docker node ls just to list our nodes. I'll just quickly clear the screen. So we've got those 2 nodes. And let's grab that next command. Just I'll leave the master node here, the placeholder, and let's copy paste it. And where the master node was, let's just grab this master node ID. What this command does, well, Docker node, so we're going to do something with the node. We're going to update the availability to drain, which basically forbid any work to be scheduled on the master node. Furthermore, it will also reschedule all the containers which are currently running on our master node. So let's give it a try. So I executed the command. It returned me the node ID. Looks like it went successful. Quick look on the service PS, and we can already see that those 2 containers are in a shutdown state. One already spin up back again on the worker, and one. And if we refresh it again, we should see 3 running containers, but now on the worker node. So our master node is not schedulable. See, what will happen now if we're going to hit our application on the master node? Because there's no instance of the application, there's no single container with our application running there. Docker PS, nothing. Well, thanks to our master node, managed node, it will handle the service discovery anyway. So I'm hitting the master node, no container is running there, but still, it will find all those 3 containers running on the poor worker. Not really an effort required here to set it up. It just works out of the box, which I think is a pretty good work the Docker team did on this bit. Right, so we played around with Swarm a little. Well, let's do a little cleanup and let's move into the Kubernetes. We'll do more or less the same with the Kubernetes. Again, we'll tell a few words about the differences and we'll set up the cluster as well. So let's just quickly remove our service from by executing Docker rm service on the master node. Again, pretty straightforward. Docker service, not create, but remove. We need to provide the name, of course. Once we did that, let's grab this command Docker Swarm leave. Let's go to our worker node. Let's get out of the swarm. So just copy paste this one. As we can see, this node exit the swarm. Well, it wouldn't fly on the master node though. If we try that, it will get us an error. We need to use a false flag as it is a node of the huge importance. It is our master node. We don't want to recklessly just remove it from the swarm. Still, we need to specify that additional flag for us to do so. So once we do that, well, our swarm is deleted, and we can move to the Kubernetes. So our last part, Kubernetes, I think the most exciting one. Let's quickly get on it. So the first things first, we need to, well, set up our Kubernetes cluster. You've probably seen some images with Kubernetes, but we don't have anything up and running yet. We just installed Kubernetes, but we didn't set up or configure any cluster. The installation itself, again, is just described in the scripts directory in the repo if you're interested, but it's basically what you can find on the Kubernetes documentation itself for the particular operating system. So we need to execute this first command with the sudo. So it will ask you for the password as you need to elevate your permission, and it will quickly initialize the cluster. It will tell you that you will have to wait 4 minutes, which sounds scary, but no worries. All the images were pre-pulled, so it will take a few seconds, really. Once it's completed, you should see something alike. Your master has initialized successfully, and you need to copy paste additionally those 3 commands. You can copy paste them from the repo, or as you can see, they are also here. So just quick copy paste of those 3. And you can also see that you've got a joining command here. So similarly to the Docker Swarm, it's just a command with a hash which allows the node to discover the master and join the cluster. So let's copy that. Well, let's hang on for a second. One more step to do before we start joining that cluster. We need to configure our networking interface. So with the Swarm, we don't really do that step. It defaults to the overlay networking, and that's our, let's say, default networking interface. Nevertheless, with the Kubernetes, we've got various networking interfaces. We've got a few options there. We're going to use Flannel for the purpose of this exercise. It's a fairly common interface used for most of the tutorials, but also in some production scenarios. Again, it all depends on your requirement. If you need any like specific networking, you might go for I don't know, let's say Calico. There's like tens of the different interfaces. The Kubernetes documentation is pretty good, so I would say if you got a certain use case, just play around, poke around over there. You'll probably find something for you. Right, so let's just grab it. Simply applies the configuration from the external YAML file. So let's do that on our master node. So that was fairly quick. And just to verify if the master node is up and running, if it's ready, let's get kubectl get nodes. As you can see, it's still not ready. And if I try it again, now it's up and running. So what some of you might have done, same as me, just cleared my joining command. Happens to the best of us. I can simply grab this, let's say, emergency command to get the new one. So I got the joining command for my worker node now. So let's join the cluster on the worker node. Oh, one more. Before you execute it, we need to add sudo to the joining command. And again, you'll be asked for the password. So just type the password provided with your instance detail, and you should be good to go. Well, provide the right one, not like me. Well, not so easy, but possible eventually. Right, so we've got another node joining the cluster. Again, we can inspect it by just typing kubectl get nodes. Still getting ready. If we check again in 1 second, we've got 2 nodes up and running. So this is the first time in our Kubernetes cluster we actually can schedule some work. Because before we just got the master node, and the master node, as I mentioned before, can't take any work. Right, so let's move to the Kubernetes directory on our master node. So let's just go cd SKS, and we'll have two simple YAML files, one with deployment and one with service. So the way the things are going in the Kubernetes, let's say by default, once you do the deployment, it won't be really available to the outside world. It will sit on the private Kubernetes network within the CIDR we specified while initializing the cluster, but the traffic from the outside won't be allowed. So we will need the service to actually expose our deployment to the outside world. Again, I'll explain as we go through files. So let's just have a quick peek on our deployment file. As of now, we don't really need to edit it. You can have a look on it in Vim. You can have a look on it in here. It's, believe me or not, it looks the same. So what's going on here? So we've got API version. We've got what kind of stuff for Kubernetes it is. It is a deployment. We've got some metadata attached. We've got some specifications of this deployment. So again, we've got familiar two replicas, so we'll have two instances of this application. What is important here will be the selector. So you will be able to, let's say, select, communicate with the servers by using this label app. And we've got a specification of and we've got a certain template here of how actually the deployment should be structured. So we've got just one container here with this image, and we added another a label with the web app. So pretty straightforward. Again, like this file is fairly simple. With a bit more complex deployments, we've got multiple containers, multiple services, and so on and so forth. We did the deployments to Swarm using the command line. Nevertheless, we can use the YAML files to describe our deployments for the Docker Swarm as well, in a similar fashion we do with the Kubernetes. And again, we can version those files, so we keep track on what's actually happened with our deployments. It gives us an additional layer of control and monitoring if we do it the right way. Right, so I'll just close this one and let's apply this. Let's create this deployment. So to do so, we need kubectl create -f, which is a file flag. Just copy paste it to our master node. So pretty quick deployment was created. And a quick look on the service. What the service will do, I called it, well, Hello Internet. Must have a bad day to come out with that name, but apologies. What it does, again, the important part here, it uses the selector with this value, which will match to our selector here. Well, it again binds the port 80 on the container to the point 80 on the service, but it will actually, let's say, expose the service using the node port. Node port, it's mostly used for the exercises. How it works, the Kubernetes will assign the random port from the range between 30,000 and 32.5. Hopefully I got it right. Might be one or 2,000 off, but as per the Kubernetes documentation, let's say, and that's the port we will be able to hit our application on. Usually we will use a different type. We would use load balancer. We would hook up our Kubernetes deployment, let's say, to our cloud load balancer or whatever solution we're using at the moment. Nevertheless, again, for the sake of exercise, we're going to use node port as it just simplifies this deployment. So let's grab this command and paste it on our master node. Again, fairly quickly it was created. So the service was created. Well, let's just have a quick look on kubectl get services now. So we should have two services. We've got a service, well, running on port 80 exposed on port 30,174. That will be a different port for you. As I said, it's a random port from the particular range. We've got another service, Kubernetes, which is, well, our cluster itself. So if we grab this port right now, put whatever the port is in your case, and if we hit it, again, it doesn't matter if it's going to be a worker or master node, the node in a cluster, you can see that the service is actually there. And you can probably see familiar unicorn or whatever the environment variable names you set on the image on your second instance. So in opposed to the swarm, Kubernetes will look locally first and then refer to the image registry if the image is not locally available. And as you can see, it handles load balancing before between the instances of the application. Well, in this particular scenario, it just load balances between two containers running on the same node. Normally, our clusters are a bit bigger, and obviously we've got a bit more to go for. But again, like I said, it's just an example to show you how the things are working. So it looks like the service works. Let's have a bit of a closer look on what's actually going on under the surface. So let's grab this command kubectl describe service, and obviously the name of the service. Commands are fairly intuitive, so let's go for it on the master node. So we've got a bit more details, obviously in name. Well, we didn't set up any namespace or any additional labels. I've got the selector, which is important for us, what type of the service it is. And also, as you can see, we've got a familiar IP CIDR, and we've got those two endpoints which are attached to this service. If we will have a look on our nodes, by just grabbing the second command, kubectl get pods -o wide, and we type it on our node, we can see that our pods, oops, I didn't get the right command. Apologies for that. Once you paste the right one, you can see the two nodes, and we can see that our instances of the application are running in the private network on those two IP addresses. And well, port 80, of course, was the one exposed in our image and binded with our service. So what's going to happen if we want to, well, do something with our application? Let's have a quick run of it and try to scale it. So to do so, we need to edit our deployment file. So I'll use Vim again, Vim deployment .yaml, and let's just change the number of replicas here in the specification. Well, I'll put 5. All right, put whatever you want, just don't go crazy. It's just a small EC2 instance, so might not handle 1,000. But yeah, any number from 1 to 10 will be fine, so pick your lucky one. So I edited the file, but hang on, we need to apply it first. The main difference between create and, well, let's say update will be we're going to use not create but apply. Same file because we just edited this file. But again, we can version our specification. We can have, let's say, well, a different schedule for the different times. If let's say we run our application in one country, we've got let's say less traffic over the night, we can set it up well a different spec for that time. Again, like we've got quite a lot of possibilities there. So let's apply this new config. Hopefully I managed to do that. kubectl is smart enough to give a warning that the resource should be already there, which it is. We already created it beforehand. So let's have a quick look on what happens with our service. We just changed the deployment and applied that configuration. We didn't do anything with the service physically, but we can see that we already have some additional endpoints here. Well, Kubernetes is handling that for us. So it just added the new endpoints from the deployment we just updated. And again, if we got on there, if we describe, have a look at our pods, we've got 3 instances of the application. And if we want to have a look and refresh a page a few times, you can see that the host name is changing to the different name of the container. So the scaling is again fairly easy. Right, so I think that was it in terms of a hands-on part. I think we got a pretty good timing, and I hope everyone could catch up. I wasn't following the questions well one by one on the comment section. So I'll probably ask my dear support and amazing support team who was helping you all here. For any questions to pass me on, pass them on Slack. To me, I will try to address them. I hope someone won the pizza. Well, we'll see. Or I hope someone will will actually get that pizza eventually. Yeah, if we got any questions, well, in terms of the workshop itself, or well, the application of the Kubernetes or Swarm, or well, some container related questions, please drop a comment or message our Slack. Well, I will stay for a minute or two just to keep an eye on supply whatever we missed here. I hope I didn't rush through the content. I hope was let's say manageable to follow. Uh, and I hope it was useful. Again, please bear in mind that we're doing it for the first time in those weird times. Normally, we'll see you in the London office with some drinks and pizza, but well, desperate times, desperate measures. So we stepped in for the online classes. Uh, One more thing, any feedback. Well, there will be hopefully a poll on our Slack channel. So, well, one of the DevOps principles is a short feedback loop and constant development. So we need to do what we preach. So please drop anything and any thoughts you've got on Slack. We'll try to take it in consideration and obviously improve on the next time. We're working on the lab platform, so hopefully at some point we'll have something a bit more professional in terms of how you're getting your instances and you're getting your content, and maybe we'll manage to do it all in the one browser window. But you need to give us some time for that. It's a community event, and we're trying to do it in a spare time. So I'm looking for the questions, but I can't see much. Well, I can see some things, so thanks a lot. I'm really glad that you liked it. Yeah, again, it's really flattering that well, we've got some positive feedback on the comments. So, which one is better? Well, I would say a very diplomatic answer would be it depends. If you want something more powerful, I would go for Kubernetes. If you want something really easy to set up and play around, I would go for Swarm. But if you look on the market share, the Kubernetes in terms of container orchestrations has dominated the market completely, and it does it for a reason. So yeah, that would be the answer. How to expand those endpoints? Oh, that's an interesting one. Honestly, I don't know out of the top of my head. That's an interesting one. I suppose if I remember correctly, you can iterate through through whatever that command return with the Go templates. At least you can do it with Docker. I think the Kubernetes goes the same way. But to be honest, I don't know the answer out of the top of my head. I'll just let's say post it in a comment afterwards when I check it. Yeah, like I said, we're just yeah, a little geeks trying to well share some interesting knowledge. So I don't know everything, but well, at least I'm honest, and I will check it for you. Yeah, I know it's a classic safe response, but well, I am a consultant, so I try to look individually on every use case. There is never a solution which fits for everyone. Um, at least that's my opinion. We can challenge me on that, but yeah. Um, Shivra, I didn't set up Kong on this setup, to be honest, so nothing to share on this side. Yeah, and the video, the stream will be recorded. Don't worry about it. And it will be on our ACS digital channel, so it will be available to well to have a look on it to do a little recap or something. I like. Apologies, I've seen that it's getting darker and darker. So just put some lights in it. Yeah, well, in this particular setup, I didn't. let's see, set up the ingress controller, we use the net node port to expose the service. Well, I can drop a link on how there is a pretty good documentation on how to set up Nginx ingress controller in the Kubernetes docs. So I can share that on in the comments. But in this particular scenario, the ingress controller wasn't set up. The way we expose the service, we use the node port in this one. Cool, cool, cool. Right, I don't see anything else coming, so I'll give it a minute. But if not, again, thanks a lot for everyone to join. Well, the turnout from what I can see on YouTube, hopefully they're not lying to us, was pretty good. So really appreciate all of you joining us, and well, spend an hour or two of your time. Really appreciate it, and thanks a lot for the feedback again. And well, I'll try to answer the questions I missed in the comments. Well, I don't quote me on that. I'll try to do a little follow-up post on the setup itself in terms of the stream and the experiences, because there were a few interesting gotchas in this scenario. Well, I still see the Kong coming in. To be honest, I haven't played that much with Kong myself. It rings the bell as a solution, but I haven't played with it that much. Well, the projects I was in required a different solution in that case. But thanks a lot for sharing that, Shiva. I hope I pronounce your name right. I usually misspell them. Sorry if I did, but well, as I said, I'll have a look on it. In terms of the ingress controller, I will share some links from my vault with you. Right, I don't see anything else going recently, so I'll close the stream. And again, thanks a lot for participating. I've got some questions about the instances. How long they're going to be alive? Well, that's up to us. So I got a request from Alex to keep them until midnight. So I think that's reasonable. So I'll leave them alive until midnight. So if you want to, let's say, go again through the content or go back and try something out, we will leave them up for you until midnight. So yeah, feel free to play around. We can do that much. So yeah, again, thanks a lot, and have a great night. And well, see you next month, hopefully, with all that experience we've got from you today, all that good feedback, and we're going to crack on next month. Obviously, it will be announced shortly. Some DevOpsy topic is coming. Yeah. Again, thanks a lot, and that's it for tonight, and see you next time.